Hello everyone, this is Shantini from Edureka. Welcome to today's session about the history of artificial intelligence and its evolution. So today's session is going to be a little different from all the previous ones. But before we begin the session, can I please get a confirmation about the video and the audio if I'm audible to you guys or not? Okay, so let's start with the agenda of today's session. So I'll start today's session with a brief history of artificial intelligence, and then I'll be moving on to the evolution of artificial intelligence. And next up, we will see how artificial intelligence works in today's world. Next up, we will see various use cases of AI in today's world. And also I'll end this session with a demo of the text-to-speech recognition system and how artificial intelligence is used in it. So let's move on. Now we have constructed cities that sprawl for miles and built skyscrapers that pierce the heavens. We have tunneled through mountains, redirected rivers and spawned new bodies of land. But it took us several million years to reach this point. But progress has snowballed since the first industrial revolution of the late 18th century. Now in less than 250 years, we catapulted from horse-drawn carts to self-driving cars, from navigating by the stars to relying on voice-activated GPS instructions, and from penning letters to loved ones to having awkward conversations with Siri. Now this world has seen four major revolutions that changed its entire face. Now the first revolution was in 1784 when the first steam engine was introduced in the world. The second one was in 1870 when the electricity was invented. The third one was in 1969 when the word information technology was introduced in the world. And the fourth one is the revolution of artificial intelligence which we are experiencing right now. So like all the other three industrial revolutions, the changes born during this period will irrevocably alter the course of our future and the way we interact with technology and each other. But in this new digital age, there will be one development so profound and seismic that it will rupture the Earth's long-held human-centric status, that is, the birth of artificial intelligence. Now, artificial intelligence makes it possible for machines to learn from experience, adjust to new inputs and perform human-like tasks. So let's have a look at the evolution of this life-changing technology from the early 50s to the present date. Now, in the 1940s and 50s, a handful of scientists from a variety of fields began to discuss the possibility of creating an artificial brain. Now, the earliest research into thinking machines was inspired by a confluence of ideas that became prevalent in the late 1930s, 40s, and early 1950s. Now, recent research in neurology had shown that the brain was an electrical network of neurons that fired in all or nothing pulses. Now in 1950, Alan Turing devised the Turing test. Now if a machine could carry on a conversation that was indistinguishable from a conversation with a human being, it was reasonable to say that the machine was actually thinking. There was also this game AI that is still considered to be as a measure of progress in artificial intelligence throughout its history. Now 1956 to 1974 was called as the golden era for AI. Many early AI programs used the same basic algorithm to achieve some goal. They proceeded step by step towards it as if searching through a maze, backtracking whenever they reached a dead end. Now this paradigm was called as reasoning as search. Another important goal of AI research is to allow computers to communicate in natural languages like English, which was also accomplished during this era. Next up was the Waybot project. Now the Waybot in 1967 built a robot that could measure distances and directions to objects using external receptors, artificial eyes, and ears. And its conversation system allowed it to communicate with a person in Japanese with an artificial mouth. Now moving on, in the 1970s, AI was subject to critics and financial setbacks. AI researchers had failed to appreciate the difficulty of the problems they faced. Now, some of the problems faced by AI included limited computer power. Now, there was not enough memory or processing speed to accomplish anything truly useful. The next one was reasoning. So many important artificial intelligence applications like vision or natural language require simply enormous amounts of information about the world. Now the program needs to have some idea of what it might be looking at or what it is talking about. But no one in 1970 could build a database so large, and no one knew how a program might learn so much information. Now in case of paradox, proving theorems and solving geometry problems is comparatively easy for computers. But when it comes to simple tasks like recognizing a face or crossing a room without bumping into anything is extremely difficult. Now this helps explain why research into vision and robotics had made so little progress by the middle 1970s. Now in case of frame and qualification, AI researchers who used logic discovered that they could not represent ordinary deductions that involved planning or default reasoning without making changes to the structure of logic itself. Another problem was the end of funding. Now, the agencies which funded AI research became frustrated with the lack of progress and eventually cut off almost all funding for undirected research into AI. Now, after facing all these problems, in the 1980s, a form of AI program called expert systems was adopted by corporations around the world, and knowledge became the focus of mainstream AI research. In those same years, the Japanese government aggressively funded AI with its fifth generation computer project. Now, this was a turning point for artificial intelligence. It experienced the rise of expert systems, a revolution of knowledge, and also the money returned during the fifth generation project. But after all this, there was another winter for AI. The second AI winter arrived in 1987 to 1993. Now, the first indication of a change in weather was the sudden collapse of the market for specialized AI hardware in 1987. Now, eventually, the earliest successful expert systems proved too expensive to maintain. They were difficult to update, they could not learn, and they were brittle. Also, the researchers complained that there was no specific body structure that they could rely upon. Now in 1993 to 2011, these years basically witnessed enormous improvement in the field of artificial intelligence. On 11 May 1997, Deep Blue became the first computer chess playing system to beat a reigning world chess champion. The supercomputer was a specialized version of a framework produced by IBM and was capable of processing twice as many moves per second as it had during the first match. Next up was a new paradigm called the intelligent agents, which became widely accepted during the 1990s. Now, an intelligent agent is a system that perceives its environment and takes actions which maximizes its chances of success. Now, AI researchers began to develop and use sophisticated mathematical tools more than they ever had in the past. Now, there was a widespread realization that many of the problems that AI needed to solve were already being worked on by researchers in fields like mathematics, economics, or operations research. Now, in the first decades of the 21st century, access to large amounts of data, faster computers, and advanced machine learning techniques were successfully applied to many problems throughout the economy. By 2016, the market for AI-related products, hardware, and software reached more than $8 billion, and the New York Times reported that interest in AI had reached a turmoil. Now, artificial intelligence has seen its growth in almost all the fields of recent times. So let's just have a look at some of the use cases of AI in our everyday life. Now, from data security to healthcare, NLP to text and speech recognition, social media monitoring to cybersecurity threats, artificial intelligence is everywhere. So let us focus on one of these use cases for our session today. Now, the text-to-speech recognition system has gained popularity in the recent years because of Siri and Google Speech. Now, the process involves processing of texts, feature extraction, and speech generation in order to convert your text to speech and vice versa. So now that we have seen how AI has evolved with time and how one of its use cases like the text-to-speech actually works. So let's move on and get into the detail of how a text-to-speech recognition system actually works. So now I'll show you the code of text-to-speech and how it basically works. Let's begin with it. So let's build a personal assistant that can recognize your voice using the speech recognition algorithm of AI and answer in spoken voice for converting the text to speech. Now, speech recognition can be done using the Python speech recognition module, and we will be using the Google Speech API here because it has great quality. And also various APIs and programs are available for text-to-speech applications. But we decided to go with the Google Text-to-Speech API, that is the GTTS. So now let's see how the code works. Now, in order to build our personal assistant, we have to import certain things here. First, we have to start with import the speech recognition as SR. So here we are importing the speech recognition. Also, I'm using the Notepad++, so I'll set the language to Python. Okay. Now, we also import the time because we will be needing the real time of our system. And import OS. Okay, now we need the GTTS. So we will be importing the GTTS from import GTTS, that is the Google Text-to-Speech. Okay, now you can install this using the pip install command. Okay, next we have to import Piglet for our audio and video, and we have import subprocess. Okay, so now we are done importing all the packages that we will be needing for our program and to run the code. So moving on, next we will define our function, that is the speak function, which contains the audio string parameter in order to convert our audio into a text string. So let's see, let's define our function named as speak, and we will pass the parameter audio string. So now this contains the audio as the parameter. Next we will print our audio string. So basically whatever audio we have here is also seen in the form of a text in our screen. Now once we are done with this, here we will define a variable named as TTS, and inside the variable we will store the GTTS audio string. So what we have to do is we just have to store our GTTS, and inside the GTTS we have our text equals to audio string, which basically will be converting the speech into a text. So we have our audio string, and here we also get to select and set our language. So I'll be setting the language to English. Okay, so now we have defined the variable TTS and it has stored the GTTS audio string, and we have also set the language to English. Now next up we have to save it. So tts.save, we are saving it as our audio.mp3. Now this audio.mp3 is basically our audio file that will give us the speech of the text that has been converted. So now the audio file is saved and we are moving on. Okay. So next up, so here I am using Windows Media Player as my default media player. You can use any other player in order to get the audio. So okay, so I have already written the code here for so that I could use it better. So I have the path set here. Now once we are done defining the speak function, we are setting up the path. So here I have set the path for my Windows Media Player so that I can directly get the audio when the text has been converted into a speech. So it is set as my default player, and I have set the file path, and now it will directly go to the media file while converting the speech. Okay, so once we are done with this, let's move on. Next up, we will be defining the function to record the audio. So what we have done here is, first we have set our function for speaking, where the audio string will be converted into a text. We have set our file to my Windows Media Player. You can use any other media player as well. Now next up, we will define the function to record the audio. So let's define that. Define record audio. Okay, so this is used for recording the audio, and for this we will need another variable that is gonna store our speech recognition and the recognizer. So basically here what we are doing is we are using our SR, that is our speech recognition package, to recognize what are we using in order to record our speech or the audio. So like I'm using the microphone to record my speech, and the speech recognition API will recognize the source that I'm using in order to record this. So it'll take with sr.microphone. As I'm using the microphone, I'm gonna set this as my source. So microphone as source. Okay, now once we are done with this, let's print something after this. So once the source is recognized, our personal assistant will just give us a signal, a thumbs up, saying that say something. So this is where you get to say something, which will be converted into a text and a speech as well. So first you say, and the speech gets converted into a text as well. Okay, so next up, once we print something, we take the audio, r.listen source. So basically inside the audio we will have our source, that is the microphone through which I'm recording anything, I'm saying anything. So our personal assistant will be listening to it through the source and then make it into an audio, convert it into an audio, and this is where it gets stored. The audio file basically is saved here. So now once all this is done, so now we will be using, this is the part where we actually use the Google speech recognition. So now we are storing the data here. Data equals to, this is where all our data will be stored, like whatever we are saying or whatever conversion is taking place from text to speech, or speech audio from to text, or whatever it is, all gets stored in the data. Now once we are recording our audio, or when we are getting the speech or the text or whatever, there will be errors and there will be exceptions. So we will set our exceptions, and we'll set all the possible errors as well. Okay, so we will check for some exceptions or errors that might occur in the code. So here we'll write data equals to r.recognize Google Audio. Google Audio. Okay, so this will basically recognize whatever audio, whatever we are speaking. So it will take the Google Audio from here. Now next up, so once we have said something, suppose I just said hi, how are you? So now it will use the Google API in order to recognize my voice and the words that I have said, or whatever audio I have recorded. So let's print you said. So this will help us get a confirmation that it's actually listening to the right thing that we have said. So it prints whatever we have said. It just converts our speech into a text. So we have our data converted into a text here, where it will just say you said. If I say how are you, it will just print you said, how are you? Alright, so let's move on, and now we will put on some exceptions. So except sr dot, now we will have unknown value errors. So in case of unknown value error, so basically if I say some word that the Google is not able to understand or figure out what I'm actually trying to say, it'll give us the unknown value error. It doesn't know what I'm actually trying to figure out, or what question I'm asking, or what actually did I say. So for this, let's just print that the Google could not recognize, couldn't understand audio basically. So yeah, let's just write couldn't understand audio. Okay, now let's put on another exception, that is the request error. So we have the request error. as E. So what happens here is, in case I'm requesting it to do something or take me to some file or location and it's unable to get into that file, or if it does not exist, it'll give a request error that whatever I have requested, it's not able to go into that location, or it's not able to fulfill my request. So here we shall just print couldn't request results. Yeah, so just couldn't request results, and just set the path as well. So we have used the request error as E, so format E. Okay, now after all this is done, the final thing to do is return data. So it will just check for any error or exception, or is there any word that it actually could figure out. Like if it figured out how are you, it'll reply I'm fine, and it'll return the data. So now let's move on. Once this is done, now here comes the important part. Now we are defining our own personal assistant that we are building for the text and speech conversion. So we will be defining our system function. So we have to name it something. So just let's name it Stan and pass the parameter as data. Data has all the speech, text and everything stored in it, and whatever we are recording, it all gets stored in the data basically. So our personal assistant needs to have this data. Now inside this data, we will just put on some example questions, such as if I just write, if I just say how are you in data, so it should speak I'm fine. So yeah, let's just write I am fine. So these are certain examples we can provide our own application. Like we can train it to how to talk or how to reply to particular queries. Okay, so you can put as many queries you want, or however you want it to answer. If you want a particular question to be answered in a particular manner, you can even put that. Now if you want your system to tell the time, then you can just write what is the time and give the C time. Like we have imported the C time package, it'll give you the real time of your system. So you can do that as well. Okay, now once we are done with this, you can define many more questions if you want to, many more queries, examples, and whatever you wanted to reply, or however you want your personal assistant, Google personal assistant, to reply to you. So now let's move on. Okay, so here we will be giving the time sleep. So we are initializing all our values of the recorded audio or our data in this section. So suppose I'm giving the sleep time of 2. If we don't respond within 2 seconds, it'll go forward. It'll go to the next step. So okay, so when my system begins and it starts talking to me, it first will tell me, what can I do for you? What can I do for you? Okay, so if I set this as the first thing that my Google personal assistant tells me, so this means that my personal assistant is working, all good. So when the code runs, the first thing that comes up is, what can I do for you? And while this happens, while this becomes true and it's working all fine, next up will be the data record. So we are storing all our data in data, that is the record audio. So we have all the recorded audio in this function. The record audio function holds every speech that we have been telling, or everything that has been recorded, or every text that has been converted into a speech. It is stored inside data. Now our Google personal assistant needs this data. So we have named it as Stan. So let Stan have all the data. That's exactly how we are gonna get the data now. So the data has been stored in Stan, and yeah, so that's pretty much about the code. Now I have added a few more questions and queries and given a proper print statement in this code here itself. It's just the same code with a few more queries in it. So now let's see, now that we have seen that what involves into the what goes into the making of your personal Google Assistant, let's move on and see how it actually works. Okay, so my file name is text, so I'll just run and see how it actually works.
Hi Tony, what can I do for you?
Okay, so you can see that the first thing that it speaks is, "Hi Tini, what can I do for you?" So I've written as what it's supposed to say when it starts working. So you can see that we get the text as well as the audio simultaneously. So basically you have the text on the screen, and as well as there's an audio, which is the audio.mp3 file, where the conversion of your text is stored as a speech. So let's check out something else. What time is it in Bangalore?
Friday, November 16th, 20 hours 25 minutes and 57 seconds 2018.
Alright, so I have just asked the time and it has given me the date, the day, the time. That is basically whatever is there in my system. So I've given the C time as my real time and it has extracted the time from my computer system and given you the exact time. Okay, so now you know that how this actually works, how the text-to-speech recognition system actually works, and all the process that includes from text to text processing, feature extraction, lifelike speech generation, and how it's converted into a speech, and also how a speech can be converted into a text itself. So you have seen the working of all of it and how artificial intelligence has played an important role in all of these new technologies that has evolved in the recent times. So with this, we have come to the end of today's session. Thank you for keeping up with this session and I hope you liked it. Also, I'll be here for another 5 to 10 minutes in order to answer your queries. So please go ahead with your questions if you have any. Thank you so much. Okay, so I can see that a lot of you have been asking for the code. So please leave your email ID in the chat section or in the comment section, and we will get back to you with the code. Okay, so let me go through some of the questions that you people have asked. Okay, so Sean S has written, if we write any AI code, does it require an internet connection? Yes, in order to run this code, you will need an internet connection basically, because we are using the Google API. So yeah. Okay, next. All right. Somebody has asked for. Okay, let me just check more questions. So do we need to install the machine? Guru Raj MP has asked this. Machine, as in you have to install whatever media player you're using, and also you just need the Google search API. If you're using this API, there are more APIs and variables that you can use. Here I have used the GTTS. So you just need that, and you just need to install your media player that you're using. I have used the default Windows media player. Okay, Hari Shankar asks which API you're using. Okay, so as I said, I have used the Google Speech API, the GTTS, which is used for the Google text to speech conversion. Okay, so I think that's all about the questions. Okay, I hope you all liked today's session. Thank you and happy learning.